So I'm going to put up the slides in a minute. We're going to look at slide number 15 in a minute. But let's look at the big picture thing first. The idea that what did we do all of this for? We did all of this to understand the properties of compounds. And eventually, by the end of this week and start of next week, we get towards other kinds of structures also that include ionic, macromolecular, metallic. What we've been focusing on so far are what we call simple molecular structures. These guys are the ones that you find as gases, and mostly gases and sometimes liquids at room temperature. Metals, ionic compounds, macromolecules are all solids at room temperature. But liquids and gases are mainly only simple molecular structures. And so our understanding is why are they the way they are? For example, why is helium's boiling point, when it becomes a gas from liquid, is minus 260 something. It's almost close to absolute zero, which is the lowest possible temperature ever possible. And that's about minus 273 degrees centigrade. Just a couple of degrees above that, or a few degrees above that, is the boiling point of helium. Itna kam kyun hai? And then why is in group 7, especially group 7 or 17 that we'll study, कि ये fluorine or chlorine gases क्यों हैं, but bromine liquid है और iodine solid है? Why is water a liquid while most other things are gases? Why does HCl dissolve in water? All of these are ideas coming from intermolecular forces and polarity. But it's not just limited to these small molecules. In the real world, you look at much more larger materials. So things about polarity का फायदा क्यों होता है? अभी हम बात करेंगे. I'm sure you've done, when you went to the video, you also saw the idea of electronegativity, the ability that some attract more than the others, the electron pair, which results in some being negative and some being positive. So we want these charge differences for attraction. Give you very practical use for this. Whenever we want to make waterproof bags, anything that's waterproof, we tend to use nylon as a material versus cotton. For those who take bio, we can categorize these two materials as hydrophobic and hydrophilic. Nylon would be hydrophobic, doesn't attract water. Cotton, the stuff that you're wearing, is hydrophilic. Pani gira sab gila ho raha tha aapka. It absorbs water. Now, very practical use for this. Anybody ever change diapers for a younger brother, sister, or cousin? Anybody? Yeah. So when all these new modern diapers, when the baby pees, there's no water anywhere. If you have a fresh diaper, it goes this thin, becomes this fat. If you really not change a diaper for a few hours and the baby's peeing, it becomes this fat with water. It's heavy, but if you were to touch it, it's dry. Because the molecules inside the diaper are polar. They are macromolecules. The same properties that you're studying for small molecules are applicable for larger polymers, which we will be studying in second year. So the reason why this chapter is so important is because it deals with, this is one of the most common use chapters anywhere that you'll be using in life. Because things that attract each other, materials that you use, is all important things. Why does a plastic bag not tear if you drip water inside it, but if you have a brown bag, paper bag, पानी गिर जाता है अंदर बैग के अंदर गीला होता है. कभी आपने भरी आइसक्रीम अगर brown bag में डाली होगी, and you carry the brown bag, after a few minutes the brown bag will tear. क्यों? Because it will get condensation, absorb the water, and weaken the bonds and break. On the other hand, polythene bags don't break. Because polythene bags are hydrophobic. They don't bond to water. And why they don't bond to water is because they are non-polar. But when they're polar, they will bond to water. So, ye bhi idea. Now, in the real world, you also know that oil and water do not mix. Oil and water don't mix. But the very large part of our practical everyday life is we want emulsions. We want things where we want water and oil to mix. To not really be mixed, but at least have equally dispersed out things. ये fertilizer industry में होता है. A lot of your cosmetic industry में होता है. The things that you use, if you're using, for example, lipstick, is oil-based stuff. It doesn't just mix in water, but it has to be spread out evenly. So, pani ke bhi, like if you use lotions also, they're a mixture of oil and water and oil, so that it is always, you can spread evenly, but if you just drop water, water flows through it. So you need water and oil to work. उसके लिए there are chemicals made which have made molecules such that उनका एक side का molecule का side polar होता है और एक side non-polar होता है. One side attracts water and one side attracts oil. Oil is non-polar, so these things are very practical in nature. Organic chemistry भरी से polarity से है. Why are alkanes so unreactive? Because they are non-polar. Why are alcohols and acids so reactive? Because they are polar. They have areas of negative and positive charge that can be easily attacked by ions. Ions attack organic compounds, which are non-polar compounds. Which are covalent compounds, can react with ions because they're polar. If the molecule is non-polar, no charges anywhere, then ions cannot attack. So all this becomes important there. So, and then why do we need to know all this stuff? We need to understand why does something have different melting points. We need to know the strength of van der Waals forces. Sometimes we've studied this in O levels. You've probably done this rough rule के MR जितना ज़्यादा होता है उसका van der Waals ज़्यादा strong होता है. And that rule exists because when MR is higher, the number of electrons are greater. When electrons are greater, the strength of van der Waals is greater. This is the second video that you were supposed to watch. So when van der Waals are greater, you can attract more. Classic example is iodine. I2, iodine. Simple molecule, just like Cl2, just like O2, but it's a solid at room temperature. And the reason why it's a solid is because it has so many electrons that its van der Waals are so strong that they need a lot of energy to break. And it's when are these van der Waals broken? When you melt and boil something. So iodine, the melting point is high and sublimation point is high because they need a lot of energy to break. Some things are gases, because gases क्यों है like chlorine? Because the boiling points are lower. Why are the boiling points lower? Because the forces are weaker, they can be easily broken. At this stage, understand that what it means to go from solid to liquid to gas. The idea of particles moving freely is in gas. So before that, they have to be held strongly आपस में. So they are attracted to each other. And the attraction has to be broken. And that attraction is really van der Waals forces. So this idea that why we're studying this, all is tied up to that. Today we're going to focus on polar molecules and polar bonds to understand why they're important. And then we knock that off first in the questions. Then we go on to van der Waals forces. So I said, now let's look at slide number 15. We're going to start off with this. We're going to be able to predict which bonds are polar and which bonds are non-polar together. Since now that we've done this stuff, I'm doing this with you right now. So between O and S, अच्छा हाँ, इसके लिए what do you want to know first? You want to keep in mind the trend of electronegativity, which is a periodic table में देखा जाए तो when you go across a period, electronegativity negativity increases, and down a group it decreases. And the reason for them increasing and decreasing is the same reason applied to ionization energy. Across a period, nuclear charge is increasing, but shielding remains the same. So effective nuclear charge is increasing. Down a group, shielding बढ़ रहा है, size भी बढ़ रहा है, they out with the increase in nuclear charge. Same reasons, and this was done also in the video also. Now, we are going to apply this. We are going to apply this idea to the the table that we've seen. Sorry, the slide that we've seen. So, this slide के लिए we'll need to know this. We'll need to know the periodic table, and keep that in mind. के यार, you got what? Carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, sulfur, phosphorus. These are the guys that will matter to us. They're trends. These are the most common non-metals जिसकी electronegativity will be used quite often. And obviously hydrogen also. And you can assume hydrogen and carbon have the similar electronegativity. इनकी values नहीं चाहिए, जबकि आपको दी हुई थी. You don't need to learn the values. You just need to know that which is the highest value here, which is the most electronegative element here, fluorine. Then is oxygen. Then is nitrogen. And then everything else. So these are the most electronegative elements. And down the group, it decreases. So applying that to the first part, इन दोनों में से कौन सा ज़्यादा electronegative है? Oxygen, because down the group it decreases. So which means relatively oxygen would have a partial negative and sulfur will have a partial positive. Okay?
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
Then uske baad these two are the same elements, that means they have the exact same electronegativity, that means this bond will be non-polar. Acha, the electrons obviously are pulled in the direction of oxygen, if I were to ask this. And if polar, which direction the electrons pulled, they pulls towards oxygen. Here this is non-polar. Then उसके बाद CN में से which is more negative? Nitrogen. So nitrogen is negative, carbon is positive. The electrons are being pulled towards nitrogen. Then iodine and chlorine में से which is more negative? Chlorine. So chlorine is negative, iodine is positive. The electrons are moving towards chlorine. Yeah. The arrows are not important for the exam. They don't ask you to make them. It's just to good to visualize कहाँ जा रहे हैं electrons. ये तो हो गया bond polarity. Then you guys had gone over molecular polarity. So उसके लिए the second part of the question जो नीचे है predict whether each of the following molecules is polar. तो इनको prediction करने के लिए आपको क्या चाहिए होता है? इनकी होती है आपको चाहिए shapes. So you got to draw the shapes first. So BCl3 में boron is in what group? Boron group 3, so 3 outermost electrons हैं. So which means boron will make 3 bonds with chlorine. If it makes 3 bonds, it will have no lone pairs. So the shape would be trigonal planar and bond angles would be 120. और इसमें तीनों के तीनों ends आपके chlorine हैं. Identical तीनों ends हैं and boron is positive. But in this case, the central atom is not the edge of the molecule. This is a regular shape. And how do we tell if the molecule is polar or not? We check for molecular symmetry. अगर सारे इसके ends same हैं, तो ये molecule क्या हुआ? Symmetrical हुआ. और symmetrical हुआ, तीनों ends पे chlorine है, तो ये molecule polar है या non-polar है? Non-polar. Good. Then next up we have HCl. This is a diatomic molecule. Diatomic molecules are easy to tell out because whatever the bond polarity is their molecular polarity. H यहाँ है और Cl वहाँ है. Which is more negative? So Cl is minus, H is plus. So is this molecular polar? It is absolutely polar. Then what do we have? Nitrogen. Then so now how do we draw for ammonia? We've actually drawn this in the exam in the video, but I'm doing this again. This is 5 electrons. So meaning it has 3 bonds and 1 lone pair. So it's going to be trigonal, not planar. That would be 3 bonds and no lone pairs. This is 3 bonds and 1 lone pair, trigonal, pyramidal. And once you have a lone pair shape, it becomes what we call an irregular shape. If any shape is irregular, understand that the central atom now becomes the edge of the molecule. Versus यहाँ central atom is not the edge of the molecule. इसमें इसके ऊपर कुछ नहीं है ना? That's one of the edges or corners of the molecule. Which means this shape will always going to be polar. We have to figure out which part is negative, but whenever you have a lone pair, the shape will be polar. So इसमें which is the more electronegative element? Nitrogen. So that will be negative and H will be positive. So this molecule will be polar. And SiCl4. Si is in group 4, has 4 outermost electrons. So what shape would this be? Tetrahedral. So you'll make the tetrahedral shape. And I'm going to draw shapes just to keep practicing drawing shapes. And this is going to be negative, 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 and positive. But because it has no lone pairs, this is a very regular shape. So this will be, the molecule is non-polar. The bonds are polar, but the molecule is. Then Slide number 16. So predict the future falling is, again, we'll draw this again in this case. So CO2, carbon is in group 4, has 4 electrons in the outermost shell. So carbon dioxide will be C, double bond O, double bond O, 2 bonds and no lone pairs, angles are 180. The edges are negative and negative. So 2 corners are negative, the molecule is symmetrical. Because the molecule is symmetrical, this will be non-polar. What about BrCl? This will have to be polar because it's diatomic and 2 different electronegativities. But which is more negative, Br or Cl? Cl is more negative. So Cl will be negative and Br will be positive. And this will be a now goes to SCl2. Sulfur is in group 6. 6 outermost electrons. Yeah. How many are bonded? 2. So 2 bonds and 2 lone pairs. So what's the shape then? Bent. Absolutely. And so bent ho gaya. Angles are 2 bonds and 2 lone pairs ki hote hain about 1 of 4 approximately or something. And will this be polar or non-polar? This will be polar because it's irregular. Our job is to figure out between sulfur and chlorine which is more electronegative. Uske liye, if you look at this table, across a period electronegativity increases. So in dono mein se yahan zyada hogi. So using that idea, I go back to the question and I get that chlorine is more negative and sulfur is more positive. And then the last bit, CS2. CS2 kya hoga? It's just like CO2. Angles are 180. And this bond is, oh sorry, these are 2 are both negative, but equally negative, so this is non-polar. And the reason why we're doing all of this is that so we can understand the kind of van der Waals. That's the main reason why doing this. Polars tend to dissolve in water, non-polars don't. Non-polars have van der Waals due to induced dipoles, and polars have van der Waals due to permanent dipoles. That's why we're doing this. Literally why we are doing this. All right? Then, can I scroll down? This is the same slide 16 mein second part hai. CF4, which some of these examples are fun to talk about. CF4 is carbon with 4 bonds. So that's CF, F and F. All 4 are F, so all 4 ends are negative. But what about the molecule? Is the molecule polar or non-polar? Non-polar. Kyun? Because it is symmetrical. Then Cl2O. Cl2O mein O has 6 electrons in the outermost shell, so O will make 2 bonds. When O makes 2 bonds, remember that O will also have 2 lone pairs. Now this is what shape? Bent. And between O and Cl, which is more negative? O. Kya hoga? Minus, and Cl will be positive. Now this is very similar to the idea of water. Just want to make this for a second. दोनों में भी O negative है और H इनमें. Now you notice इन दोनों का polarity भी same mark हुई है, सब कुछ same mark हुआ हुआ है. Shape भी वही है. But what they can ask you is, which of the 2 molecules में there's greater polarity or greater bond polarity? Meaning जहाँ electronegative difference ज़्यादा होगा, वहाँ polarity ज़्यादा होगी. O and Cl में दोनों electronegative elements हैं, but H is not electronegative. So यहाँ ज़्यादा polarity होगी, यहाँ कम होगी. It's like saying कि between, give me another example. between Cl and F and I and F में किस में polarity ज़्यादा है? The greater the electronegativity difference, the greater the polarity. अब that means कि group 7 में ऊपर F है, फिर Cl है, फिर Br है और फिर I है. F और Cl में इतना फर्क नहीं है, but F और I में बहुत ज़्यादा फर्क है. Because down the group it decreases. तो यहाँ कम Cl has less than F, but I has way less than F. So इन दोनों में से ज़्यादा difference किसका होगा? ClF और IF? IF. Which means आप दोनों को लिखेंगे delta plus and delta minus, because fluorine will always be minus, but ज़्यादा polarity कहाँ होगी? IF. We therefore say in English that this molecule has a greater dipole moment. The word uses dipole moment or has a greater overall dipole. इन दोनों में पानी और Cl2O में, H2O and Cl2O में कहाँ ज़्यादा dipole moment होगा? H2O, जहाँ difference ज़्यादा होगा. Are you following that? So that's because you are not quantifying this. If we could, this might be a 0.1 difference, but this would be a 0.3 difference maybe. But we don't quantify it because we can't quantify it. We know it's partial. But we can qualitatively say that ClF का जो partial charge है वो कम है और IF का partial charge difference ज़्यादा है. And क्यों? Because of electronegativity difference. And this was part of the video also, that if the difference is too great, that's how you become ionic bonds. Because जब इतना ज़्यादा फर्क होता है, that's what leads to ionic bonds. जब कम होता है तो covalent bonds. जब कम में भी बहुत कम होता है तो non-polar covalent bonds. But अगर medium है difference है तो वो बन जाते हैं polar covalent. So these are both polar covalent. इनमें भी variation है. This is less and this is more polar. And the reason I'm saying is because आगे जाके जो examples आते हैं like NCl3. Now ये भी वही बात है, NCl3 versus, like I'm going to show here, NCl3 versus NH3. दोनों आपकी हैं क्या? Trigonal pyramidal, NCl3 और NH3. But दोनों में वो overall dipole किसका ज़्यादा strong है? Which is a greater overall dipole. दोनों में N negative है, but since Cl is also electronegative थोड़ा बहुत, तो ammonia में greater polarity है और इसमें कम है. And that also comes in handy in the real world because that's how you determine intermolecular forces, that's how you determine solubility. कौन dissolve कर रहा है, कौन नहीं कर रहा, stuff like that. All right? Yeah. So that's this. हाँ, one last molecule दिखाना आपको मैंने. यहाँ तक कर लिया आप लोगों ने? Can I change this? Just to put all of that we've done together, and to now you can realize how much more you know. Because a lot has happened in the last few days that puts everything in place. Okay, you can now be able to draw the shape of ethanoic acid, understand its reactivity, polarity, everything. You know it's an acid, right? Now you should realize that, okay, you know what, you can make not just the bonding, but you can make the shape. Because CH3 में, it's a tetrahedral structure पहले, because it's bonded to, actually no, I should make the bond first for you. So CH, this is how you would make in the O levels. CH3, CO, OH. Hi. This molecule, if I focus on this carbon, how many bonds does it have? 4. So the shape would be tetrahedral. If I draw that, you got the shape right now. You know it's tetrahedral, so the bond angles are, all of them are 109.5. But now focusing on this carbon, what do you get? This carbon has 3 bonds, 2 single and 1 double. So that would be trigonal planar. So CO and O. And you might want to put H there also, but you realize that no, this OH is also a bond, and O would have to have single bond here, a single bond here. And so, but O has 6 electrons, so 2 single bond means 2 lone pairs. So the shape would be bent. So now you can also draw this. And that explains a few things about the shape also. You can now draw all angles. You can literally predict every single bond angle in molecules now. And why that matters is then they shape and then the way they react, all of that is part of this. You can also realize that now this carbon has got 2 oxygens, which means this carbon is really, really positive, while the 2 O's are really, really negative, which makes this H really, really positive, which is why when this dissolves in water, this bond easily breaks, and you get what? H plus. But you also know it's a weak acid. So you know, kuch टूटता है, but सब नहीं टूटता. So that means this breaks less than HCl does. But this is where the acidity comes from. And I'm going to end this class.
Hey there! If you found this A-level chemistry lesson helpful, why don't you head over to our website, altacademy.org, where you can sign up for the full A-level chemistry course. In addition to chemistry, you can sign up for physics, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for?